All right, this is question 20. We're given a lot of information for the different triangles, so it's good to just follow those through, but it's all on the picture given. Um, so the first thing it says, show that x equals h cot alpha. So straight away I can see it's got cot alpha. I'm not so good with cot, so I'm going to go straight to tan alpha and have a look at what tan alpha is. So I know because it says x and h, I want the x and the h in there, so I'll go straight to tan alpha and look for the x and h. Yes, it has opposite over adjacent is h over x. And then once I've written that, I can very easily go to, that's a bit fat, let's go like that. I can very easily then go to x equals h cot alpha because cot is just the inverse of tan. So to put um, our tan alpha on the other side of the equation, what I'm doing is the reciprocal, so 1 on tan alpha, which is cot alpha. All right, so hopefully that's okay. Now if I go into, I might as well write all the information down that I can, and it does ask for a similar expression for y. So if I do exactly the same thing in that other triangle, I can see that tan beta equals h on y, and if I put my tan beta on the other side, it becomes cot beta, the reciprocal. So I've got these two lovely equations that I can use later. And while I'm there, we've got three right-angled triangles in this picture. So it does say to use Pythagoras theorem for the next one. So while I'm up here looking at all the conditions, I'm going to use Pythagoras theorem. So I get, excuse me, I get three equations using the three different triangles. I've got PA squared is h squared plus x squared. I've got PB squared is h squared plus y squared. And also in that, the triangle at the bottom, I've got AB squared equals x squared plus y squared. So that's the three right angle triangles. So, excuse me, so the three right angle triangles, I've got these three equations using Pythagoras theorem. So there's a lot of just information right there that we can use for later on, which is very handy. So the second part says use Pythagoras and cosine rule to show that cos theta. Now where's theta? Theta comes from, so there's that triangle that's, we're given PBA, and we're given that this angle here is theta. So it's this triangle on top almost. So if we use cos theta in this triangle, the cosine rule in this triangle with cos theta, we get this equation here. Cos theta is PB squared plus PA squared minus PA squared on two lots of PBPAs. Now, using all the information above that we've got all these equations up here. If we substitute all of these into that equation, we get this lovely equation here. All right, if we simplify that a little bit, we go down to here. So it simplifies really nicely. The 2's cancel. Sorry, it's not great. It's a bit blurry. And we get this equation h squared on square root, which is what we wanted to get. So we got what it asked us to prove. So that's great. So they were just using all the conditions. Then it says, hence show that sine alpha sine beta equals cos theta. All right. So let's go back to sine alpha. Alpha came from that triangle APQ. So if I go back to sine alpha there, I get some old hag, so I get the hypotenuse, which is h, sorry, I get the opposite, which is h over the hypotenuse, which is AP or PA. And sine beta, if I do the same thing. So just finding the ratios for sine alpha and sine beta in their triangles, their right angle triangles. And then if I multiply those, so again, just multiplying them, I get this nice answer, h squared on PA times PB. And then we know that PA is just from up here, the square root of h squared plus x squared, and PB is just the square root of h squared plus y squared. So we can substitute those in as well. Now, when we do that, you can see that it is exactly the same as this answer we got over here. And this answer is cos theta, therefore we get cos theta for sine alpha times sine beta. All right, so the part 3 or part 2 even usually is using the part above, so look out for that.